Okay. So the what we are required here is that we need to divide this into in a way where this is 0.75. So we did discuss a formula yesterday. It's
Yeah, it was like it
yeah.
was where you had the resistor or the component in parallel over all the resistance times the
Yes.
voltage of the
So
supply PD.
V is equals to the supply PD divided by R1 plus R2 plus R3. Okay.
And then you times it by the supply PD.
Hmm. So this was R3, the required resistance. I don't
Yeah,
know.
no, as in like right next to that fraction you write times the supply PD, don't you?
Mhm. Yeah. So the supply PD is actually the epsilon.
But can I ask you, when you mean what do you mean by epsilon or however you say it?
Epsilon is basically the supply PD, the total volt that is attached in the battery that is being supplied
Oh,
actually.
so wouldn't it be V out equals all of that times supply PD?
Mhm. So the formula that we discussed was this formula. So V1
Yeah,
is
yeah, yeah.
equals to this formula, all right? So that's what we're
Yeah.
gonna do here. So R3 here is the okay, I'm just gonna write uh, this is R1, this is R2, and this is R3.
Yeah.
Okay, so the voltmeter reading is equals to epsilon times R3 divided by the total resistance. And the okay, so let me just the LDR is so the R1 that is given to us is 5 kilo ohms, if I'm right. Yes, and the resistance of R is actually 5. We need to find R2 only. That's yeah. So what we did was that V was equals to epsilon times R3 divided by R1 divided by R1 plus R2. So we have everything except R2. We have R1 to be equals to 5 kilo ohms. R3 is also 5 kilo ohms. V is given to be 0.75 volt because that's how much we need. And epsilon is, I think, 6 volt battery. It's a 6 volt battery. So epsilon is 6. And all we need is R2 from here. So we're just gonna plug in everything in the formula and then we'll just find R2. Okay.
Oh, yeah, I got it. Sorry, my mic was muted again.
So 0.75 is equals to 6 times 5 into 10 raised to the power 3 times 5 kilo ohms plus R2 plus 5 kilo ohms. So this is equals to this is actually equals to 0.75 times 10 kilo ohms times R2 is equals to 6 multiplied by 5 kilo ohms, and R2 is equals to 6 multiplied by 5 kilo ohms divided by 0.75 minus 10 kilo ohms. So 30 divided by 0.75 minus 10. So R2 needs to be 30 kilo ohms. That's the correct answer.
Wait, can you just let me copy that for a moment?
Yeah, I'm just checking if I've done it correctly or not. So yeah, 30 kilo ohms.
All right, just hold it there for
Yeah,
a
yeah.
moment.
You sure, take your time. I can send you the solved PDF as well if you want.
Yeah, I have the solved PDF. It's on the website. It's just they used a different method, which is why it confused me. But you used the method that I used. I just I just did it slightly incorrect. So thank you for the help. All right, just let me copy this and I'll be right there. All right. All right. Thank you very much. Yeah, I've got it down. All right.
Okay. What's next question?
Just let me have a look again. It was like 4. Where is the question? All right. Yeah, just give me a moment. Yeah, it was it was 4B and all of 4C.
Okay. Okay. So,
You know where it shows the ad closed by Google?
mhm.
Like, you know the scrolling thing on your right. Yeah, there you go. Now you've covered it. Yeah, there you go. Yeah. You know where it showed that table, 4B?
Yeah, I just
No, scroll. Yeah, there you go. Of all of 4B and all of 4C.
okay. The total resistance. Okay. So calculate the current in the battery. A high resistance voltmeter is used to measure the potential difference between the points A and C, D and F, C and D. In turn, complete the following table indicating the reading. So A and C, and sorry, it's AC, D, F, and CD. Okay, so you know that this is a 12-volt battery and these two connections are in parallel. So 12 volt is entering here and 12 volt is entering here.
Yeah.
So the voltage drop basically is, we'll just use the formula for the potential divider, that is V is equals
Oh,
to,
can I just so as you're speaking, I'll just be copying it down, okay?
okay, okay. So this is 12 times 20 kilo ohms divided by 20 kilo ohms plus 20 kilo ohms. So V is actually equals to 6 volt. So AC is 6 volt. 6 volt. So you'll just write this is 6 volt and DF.
Oh, the rest is just 12, right?
Yeah, no.
Okay.
The DF this. So
Yeah.
if you're going to measure DF, so this is 10. The resistance of the thermistor is 5. Now what's the resistance? Okay, okay. So the resistance of the thermistor is 5, so it's gonna get divided. Voltage is gonna get divided, and this is gonna be 8, and this is gonna be 4. So there is a trick to it. I'll just tell you after we do this question. So DF is going to be 4 volt, and now the actual potential difference is, I think, should be 2 volts. If I here it is. Here at this point, this is there are 6 volt remaining, and at this point there are 4 volt remaining. So if I attach a voltmeter from C to D, then it is going to be 6 minus 4. The potential difference is actually going to be 2 volt.
Right. Okay. Can you re-explain that again?
Hmm. Okay, so the thing is that obviously since we these two connections are at A and B, the connections are in parallel. So
Yeah, yeah. So the voltage is going to be like the same.
to every parallel to from A to E, the potential difference is going to be 12, and from B to F, it's going to be 12.
Okay. Yeah.
Okay. So now they're asking us to actually calculate the potential difference that there will be in from A to C. Now, if I basically what they're asking us is to just calculate the potential difference that this resistor is actually using.
Yeah.
So
Okay.
12 volt enters this line, and since this is 20 and this is 20, so the voltage gets divided equally. So this is 6 and into 6 and 6. Okay. And if you want to do it,
Oh, okay. That's like a sneaky way.
yeah.
All right.
So, and here the method is that since this is 10 and this is 5, so it gets divided into the ratio of 2 and 1. So this one
Yeah.
gets 8 and this one gets 4. Okay.
Yeah.
And so if I attach a voltmeter from D to F, like they've done in for this part, DF, there you're
Yeah.
going to see a potential difference of 4 volt.
Okay. All right.
Okay.
Just can you just let me copy this down?
Okay. Yeah. Just sure.
Yeah, there you go.
Is it? Are you finding these questions easy? Now that I've explained it.
I found after covering the topic, I found a lot of them easy. It's just the ones that I found relatively difficult. I wanted to go with you since
Yeah.
obviously you're a
Sure.
teacher and you know a lot more.
Mhm.
Can you repeat how you got C to D again? Is it just using the equation?
No, the concept is that at C we have 6 volts and at D we have 4 volts. So the potential difference, the difference is actually the potential difference, basically. So 6 minus
Oh, so it's
4.
like the diff. So 6 minus 4.
Yeah.
All right. Okay. All right. Then thanks a lot. Can we do uh
C part.
4CI?
Okay, so for C,
The
the
thermistor is
thermistor is and decreases explain the following position AC. So AC has no, so actually the thing is that we have to find what effect does it have on AC. The thing is
Uh-huh.
that the thermistor is not in the same branch as of AC. So each branch, since in parallel circuits, they get 12 volts.
Yeah.
So whatever, so whatever resistance of is there of the thermistor, the branch of AC will still be getting 12 volts. So there we will see no change in AC with whatever resistance is there. Do you get it?
Yeah.
So no change. And DF.
Wait. Can you just give me a moment? Sorry.
Oh, yeah, right. Just I was saying no change.
Yeah, and you want to carry on?
Okay, so the part two, in part two, we're asked how will the potential difference be affected if we change, if this resistance decreases from D to F. So the question is like simple since what just happened.
Yeah.
Okay, so in here, since the resistance is decreasing, the resistance V is I is equals to IR, so R is decreasing, so V will also decrease. Why? Because it will consume lower proportions because of that's directly proportional to the resistance if the current remains constant. Okay.
Yeah, you know where you said how resistance will decrease and so will voltage. Can you repeat what you said after that?
Okay. So we have to state the effect on the voltmeter reading. So basically the voltage across that. So we have to write V is equals to IR, and R is
Yeah.
decreasing, then V will also decrease. And since they are in series, since D, E, and F, I want to say, what are the points? B, D, and F from,
Yeah, they're in the same branch.
yeah, so from B to D to F, current is constant because it's in the series.
Uh-huh.
So if R decreases, V decreases. So it's basically the direct proportion thing. So V is equals to IR and I is constant. So R will basically be decreasing. R decreases, V will decrease.
Is greater proportion of both.
Okay. Uh,
Uh, Oh, okay.
Okay.
As the- all right. Let me see what other questions I want you to go through with me. Can you go over 5A? I know it's a relatively easy question, but I don't know. I've never really like had the definition of one.
Okay, so volt is work done per unit charge.
Oh,
So
oh,
it's
so it's just
equal.
W over Q.
Yeah.
Oh yeah. Isn't that an equation for voltage as well?
Yeah. I suppose they've written also the same answer. I'm just going to refer to the marking scheme.
Oh, so I know this then. Oh
One
wow.
joule per so that's volt. So work done is what they've written is 1V is 1 joule divided by 1 coulomb. So they've just written this.
Oh, all right.
Okay. Do you want me to
Yeah.
discuss part B?
Wait, just give me a moment per. Wait, per unit coulombs. There you go. Let me have a look at question B and whether I got it, whether I understood it properly or
Yeah,
not.
sure. Take your time.
To test the potential difference, a student sets up the circuit of figure 1. R1 is the resistance of section AB and R2 that of section BC. The voltmeter reading. I think I got question 5BI correct, but just to be sure, can you go over it?
Okay, they say it's like a potential divider again. So
Yeah.
a student sets up this, so R is the resistance AB and
Can I tell you what
R2.
I did?
Yeah, sure.
Um, I did because R1 is like in the area of the potential divider. I
Mhm.
did 2.2 plus 1.8 is 4. So that's like the total EMF. And then 2.2 is in the potentiometer area. So I did 2.2 over 4 times 9 because 9 is the voltage. And then I got 4.95 volts. But like I think it's right, but I want to like check it,
Yes, that's the correct working. It's this formula again.
Yeah.
This formula.
All right, okay. Thank you. All right, can you go over 5BII?
So
Reduce current. Wait, what?
you-
That's how it's. Oh yeah, I got it right then. Let's go.
and what did you do in part 3 and 8?
No. In part 2.
Okay. The part 2. They're saying, okay, state the benefit of using a high value of resistance and potential divider circuit. So high value of resistance means low current because the volt V is constant. V is equals to IR. This is constant for the search for the battery. For the EMF, the battery will always be providing 6 volts. So if I increase the value of R, current will decrease. So low current.
All right.
Okay.
Okay. Could you go over part 3 as well?
Is connected to replace the voltmeter. This is calculate the potential difference across is sliding contact B is okay. So what happens is that okay, so I would say that across this resistor when the sliding contact is this, so voltage is 9. Is it 9? I don't think it should be 9. It should be whatever the value. Let's just let me think on this first. This was also 2.2 and 1.8. 2.2 and 1.8. So shouldn't it be 2.2 times 9 divided by 4. So
That's what we did for the last question.
mm, mm. Yeah, that's exactly what I'm thinking. So so this is 4.95. This was 4.95 volts. So 4.9 volts. It's either 4.9 volts and no, it shouldn't be like this.
Maybe we should look at the mark scheme.
No, just let us just think on that. This, I want to say that because the thing is that this voltmeter, instead of a voltmeter, they have just made a resistor. So yeah, the thing is that uh, this is a branch and this is also a branch.
So it wouldn't be out of 4. It would be 2.2 plus 1.8, which is 4 plus 8. So it'd be 8 out of 12.
Hmm. So no. Oh, but the thing is that what I'm thinking is this eight kilo ohms resistor is actually parallel to the whole thing, but it is not. It is only parallel to 2.2. So the thing is, so the circuit then becomes something like this. It's something like this. So this is the image that is in my mind. So that's what I'm thinking. 2.2 divided by 8 and 1.8. So, okay, do you get it?
Yeah.
So it's something like this, which means that we have to calculate the total resistance of this circuit. So it's 1 over R is equals to 1 over 2.2 plus 1 over 8. So 1 over 8 plus 1 over 2.2 divided by answer. This is the total resistance R comes out to be 1.725 and this is 1.8. So it should be equals to, V should be equals to 1.725 times 9 divided by 1.725 plus 1.8. So 1.8. The answer for me is 4.404 volt. Do you get this thing?
Kind of when I get to the answer, hopefully.
Yeah, 4.4. So this is the image that you should have in your mind.
Oh.
So it is now what you have to do is, so you have to calculate the total effective resistance of this parallel portion, which you will do it like this. So the answer comes out to be 1.725. And using this resistance, we will know how much each branch of this will get. So since this is in parallel, so we will be actually dividing the voltage according to the total effective resistance of this parallel portion of the circuit.
Wait, just let me just get my calculator. I want, wait, you're actually right. With, so 1 hour, 2.2 plus 1/8. 1.725. Okay. Times 9. I think you did it a bit wrong.
This one?
No, as in like the answer is 4.4, but you got 4.04, and I got 4.4 as well.
Oh, I got 4.404 actually. This is, yeah,
Okay. Oh, never mind then. Wait, let me, I want to copy this question down.
sure.
Oh, you've actually dumbed it down a lot more. Thank you very much, sir. Thank you. All
Okay.
right, so wait, so it's like this. One point eight. All right, yeah, thank you very much, sir. Um, I want to see some other questions where I may have found difficulty occurring. Uh, let me see. Could you go over question 5B IV. Yeah, so you know the one with the two resistors in
Okay,
series. Yeah,
so
yeah, the one you're on right now. There you go.
mhm.
Yeah.
So and with the potential divider arrangement, so
Can I tell you what I put and then see whether it's wrong or right?
mhm.
Uh, um, I put because they're in series, obviously, the current would still be reduced by the 8 kilo ohm resistor, as the variable resistor has a lower resistance compared to the 8 kilo ohm resistor. And then I put for another point, a potential divider would allow for some uh current to still pass compared to if they were in series. I think I'm into it, PD maybe.
So the first thing that you mentioned is obviously correct. So the total effective resistance has increased in this case. So there, the total resistance is 12, and here it was something around 3. So if we increase the resistance, the current is going to decrease current.
Uh-huh.
So that's the first point. The second point is about the potential difference across this thing. So the thing is that I don't think that the potential difference is going to change because the total resistance then it would be always 4 kilo ohms. Okay, so this arrangement isn't like for me this isn't potential this isn't in the sort of variable resistor where it can go to 0 to 4. It's the total resistance of this will
Yeah,
always be 4. Okay,
yeah, there you go. Yeah.
so the potential difference for me is obviously going to be it will then get divided from 4 to 1 ratio. So this is 2 and this is 1 ratio. So this will get 6 volts now and this will get 3 volts. So now that this 8 kilo ohms will be uh, this, so it will just have higher PD across 8 kilo ohms resistor. I think I don't think they've told us to do this. They've only asked for this point. So they haven't asked us to write about the second point. They're just saying in the question, they say compare this arrangement for controlling the current in 8K resistor with the potential divider arrangement in figure 2. So we have to compare the current with respect to this. So the first thing that we need to write is that there is a decreased current within the circuit, and with respect to the total, with respect to the current that is coming into for the 8K resistor, what we're gonna write is that right now it will remain constant. It is, since here it was this 8K resistor was actually connected in parallel, so the current was getting divided in 8 and 2.2. Okay, so this was getting more current and this was getting less current. So
Yeah, but that's like a potentiometer and a potential divider. This is in series. You know what I'm saying?
yeah, obviously, so there is a difference now. So the first difference that we'll write is for the decreased current that is
Can I
throughout.
ask why it's decreased current? Like the point is that, but like why?
Oh, okay. So it is decreased because the total resistance is now much higher. So the total resistance of this
Oh
circuit
yeah.
is around 12K And here it was very less. It was, I think, 3 something.
All
Just
right.
looking
Okay.
at this. Okay, so that's the reason that there is decreased current in the circuit. And within the 8K resistor,
Uh-huh.
uh, current is current was dividing in figure 2 because it was
Mhm.
connected in parallel.
Yeah. I got that because there's a lot of because in parallel you have to divide it.
Hmm.
Yeah.
Just
And then
okay.
why does it say from 0 to 1.1 milliamps? Like where did the zero where did the 0 to 1.1 come from? Like I know that you can control the current with a variable resistor, but why 0 to 1.1?
Hmm. Okay, so 1 point, where is this 1.1 coming from? That's a good question. Can provide sensitive control of current. So
Oh, where?
they might have like given a question here where they ask you, okay, the total current is 1.1. Calculate the voltmeter reading. No, no.
No, but yeah, but that's like a whole different question. I think that talking.
Hmm.
Yeah.
So, oh no, it's a 6 part,
Oh, no,
six.
never mind. It's fine. It's fine.
So that's why. Okay, so the thing is that potential divider is actually like controlling in like in figure 2. If I bring this thing to 0, if I bring this thing to till here, then the amount of current that will be there in the 8 kilo ohm will be equals to the 9 divided by 8, 9 volts divided by 8 exponent 3. So this will be 1.1 milliampere something. Okay, so that's the maximum current.
Oh.
Okay, so
Wait,
for
wait. So it's 9 divided by uh 8 times. Oh, how come we're doing 9 divided by 8K?
because then this will if I bring this B arrow to this point, then
Uh-huh.
this will be the actual circuit. So this will be the potential divider, and this will be
Uh-huh.
the 8K resistor.
Oh, okay.
So this will be the 8K resistor, and this will be the potential divider. So in this case, so the 9 volt will be going here and here. So that's the
Oh, okay.
maximum current. But
Okay.
if I sort of control the current using the potential divider, then we have an image like this, the one on the left.
Okay. Wait,
Okay.
so 9 divided by 8 times 10 to the power 3. Okay, yeah, I get it. All right, yeah, can you scroll down and continue your answer, please?
So current was dividing in figure 2 because it was connected in parallel, and changing R1 changes current in 8K resistor. So it's giving you a control from 0 to 1.1 milliampere. Okay.
All right.
Do you get this?
Uh, yeah, do you mind giving me, can you scroll back up yeah, to this one? Yeah, can you scroll slightly down? Just slightly. Yeah, there you go. There you go. All right. Can you give me like 2 or 3 minutes to copy this down?
Sure, sure. Take your time.
Okay. Wait, just nearly there. Can I ask you something?
Yeah, sure, go ahead.
You know how I said for the potential divider, it can control the current from 0 to 1.1 milliamps, and we do 9 times 8,000 to get 1.1 milliamps. But how come we don't include the other resistance? You know how we had 4.9 ohms?
Yes.
Yeah, how come we don't include that too? Like, wouldn't it be 9 over 8,000 plus 4.95?
4 8 over, so 9 over 4.95. Okay. Oh,
No,
so
no, like wouldn't it be 9 over 8 times 10 to the power of 3 plus 4.95?
no, no. Actually, the thing is that it will be something like this. So,
All right.
so this is 4, and this is the 8K resistor. So basically,
Uh-huh.
there is actually 0 resistance here, and there is 8 here. So all the current
Yeah.
will then pass through here. This.
Oh, okay.
Okay. So this will get
Okay.
0 current, 0 amperes.
All right. Okay.
Okay.
Could you okay. Um, so Wait, I want to wait. What was the question again? Uh,
The question was,
compare the.
how does this arrangement differs from this arrangement? And we have to talk about specifically with the 8K resistor. So the current around the
Yeah.
8K resistor.
All
So
right. Potential.
yeah,
All right. Yeah. Can we do question 6AI?
um, calculate the current in the circuit. The shows two resistor in series with negligible in internal resistance. Oh, you really want to do 6I, so the total effective resistance is 8 plus 60, so 68, and I
Yeah, but
is,
isn't 8 the voltage, not the resistance?
sorry. Okay, sorry about that. So the reading on the voltmeter is this much. So how much should be the so we're just going to use this to calculate the R1. So uh, V is equals to epsilon R1 divided by R1 plus R2. So V is 8 and the total voltage is 12. So 12 times R1 divided by R1 plus 60. So this should be equals to R1. You will get the answer 120 ohms. And the current in the circuit will be 12 divided by 180. So this will be equals to, what's 12 divided by 180? 12 divided by 180 is 1 over 15 or 0.067.
It's 6.7 times 10 to the power of minus 2.
Yes.
Wait, can you tell me how you got R1 is 120, like the working out?
Oh, just solve this equation.
Wait, actually. I got that answer at first, and then I was like doubting myself. I was
Oh,
like, oh,
no.
is this right? All right. Yeah. Wait, could you show me the working out for R1?
Yes.
Yeah, please. Thank you very much. Hello, sir.
Yes. Hello.
Hello.
Hello. Hello. Yes. Do you want me to solve part two as well? So this is the part two solution for part two.
Sorry, your voice, I didn't hear you for some time, but all I'm asking, in case you probably heard me or you probably didn't hear me, but I wanted to know how you got the working out for R1, like how you got R1 is 120 ohms, basically.
Oh, so R1 is 120 ohms. This is the equation of the potential divider again. So V
Yeah,
is
I know that, but like, can you show me how you rearranged it, basically?
uh, so this would be 8R1 plus 480 plus equals to 12R1 and 4R1 is equals to 480 and R1 is equals to 180. Okay,
Wait, just give me a moment. I want to copy that down.
sure, take it out.
How did you get 4R1 equals 480? I get, hey, can you explain that? Sir, you're muted.
Oh, okay. So you take 8R1 to the right side of the equation. So 480 that equals 12R1 minus 8R1. So it's algebra.
Sorry. Yeah, that was stupid. All right, 8, 12. So 480 equals 4R1, and then divide it by 4 equals 120. And then calculate V over V over R. So that's
Have you copied this down?
yeah, I've got it.
Okay, so
And we also don't need to do part 2. Wait,
mhm.
I want to do part 3 myself. Wait, calculate the charge to the battery was Q equals IT. So yeah. 6.7 times 2 times by 120 equals 120 equals 8. Can you check on the mark scheme whether part 3 is 8.04 coulombs?
Yeah, 8.0.
Oh, 8.0. Oh, I did it to 3 significant figures.
Okay.
Wait, can I just check question the last question 6B?
Sure.
Wait, I want to see it for myself and then I'll ask you. All right.
Okay, yeah, sure.
Wait, okay, the resistance will decrease as the allow for a higher reading will increase resistance of the. Oh yeah, I got the last question correct. All right then.
Okay, so I think this is the end of the worksheet, and
Yeah.
okay, so I'm gonna send my PDF to you,
Uh-huh.
and I I hope everything's clear after this.
No, you don't need to send it to me. I got all the working down.
Okay, you have all the working. You don't need
Yeah,
the.
I have all the working. I
Okay,
have a physics class tomorrow morning, so I can ask my teacher stuff as well.
okay, all right. So I think this is it for today then. It was nice
Yeah.
talking to you today, and inshallah, we'll leave a class next week then. Okay,
All right then. Thank you very much, sir. Have a good
thank
day.
you. Assalamu alaikum.
Bye.